So now we'll discuss this lecture, the residuals in artificial intelligence. Residuals in artificial intelligence generally refer to the difference between the actual values and the predicted values. So they are critical concept for evaluating model performance, then diagnosing errors, and improving predictive systems, improving the prediction. Now, the definition of residuals are computed as a residual is equal to actual value minus predicted value. They measure the error or deviation of predictions from the ground truth. So, the importance of residuals is that they help evaluate the model performance. They indicate whether the model is underfitting, overfitting, or performing appropriately. They also provide insights into whether assumptions of the model are valid, whether the assumptions of the model are valid. Now, residual analysis is the examination of residuals to assess model accuracy and quality. So, residuals are visualized through residual plots, that is, the predicted versus residual values, to detect the patterns and biases. Now, residuals in regression models, residuals show how far off a model's predictions are for each data point. How far off a model's predictions are for each data point. Ideally, residuals should be normally distributed and show no pattern when plotted against predictors. So, they should be normally distributed and show no patterns when plotted against predictors. Now, in neural networks in deep learning, residuals are used to compute the loss function, which the model optimizes during the training phase. So they are critical for back propagation as they determine the gradients for updating the weights. While residuals are closely related, residuals are computed using data available, that is sample. Errors are true deviations, often unknown in real world scenarios. They are often unknown in real world scenarios. Residuals are computed using the data available. Now, residual of sum of squares, a common metric to quantify residuals, it is the sum of squares used in regression models to measure the total error. Homoscedasticity versus heteroscedasticity. Homoscedasticity means that residuals have constant variance across predictions. And heteroscedasticity is that residuals have non-constant variance, indicating issues with the model like missing variables, the non-linearity. Now, residual plots. Tools to visualize residuals and detect problems in the model, like scatter plots of residuals versus predicted values, QQ plots to check normality of the residuals. A random scatter with no patterns suggests a good model fit. A random scatter with no patterns suggests a good model fit. In gradient descent, residuals directly influence gradient computation in models trained via gradient descent. The magnitude of the residuals dictates how much the model updates weights and biases. Residuals in ensemble methods. In methods like gradient boosting, residuals from the current model are used to train subsequent models in a sequential manner. So, in ensemble methods like gradient boosting, residuals from the current model are used to train subsequent models in a sequential manner. The goal is to minimize residuals iteratively. So the goal is to minimize residuals iteratively. So in residuals in ensemble methods, in methods like gradient boosting, residuals from the current model are used to train subsequent models in a sequential manner. The goal is to minimize the residuals iteratively. Now, residual connection in neural networks. Residual connections used in architectures like ResNet are different from traditional residuals. Residual connection in neural networks. Residual connections used in architectures like ResNet are different from traditional residuals. They skip layers by adding input features directly to the output. They help in training very deep networks by mitigating the vanishing gradient problem. Now, residuals may not always be independent or identically distributed, may not always be independent or identically distributed, especially in complex models. High dimensional data and nonlinear relationships can make residual interpretation difficult. Residuals help identify outliers, missing predictors or features, nonlinear relationships, multicollinearity, or interaction effects. Now, residuals in classification problems. Residuals are less intuitive in classification tasks compared to regression. Residuals are less intuitive in classification tasks compared to regression. In classifications, residuals can be defined as the differences between the probabilities true class probability minus predicted probability. Assumptions about residuals. Standard modeling assumptions about residuals include independence of the residuals, normal distribution of the residuals, zero mean of the residuals, no correlation with the predictors. Now, residual metrics. Metrics derived from residuals include mean absolute error, mean square error, root mean square error. Residuals in time series. Residuals help analyze model fit for time series prediction. Residual autocorrelation is checked to ensure no patterns remain in errors. Residual autocorrelation is checked to ensure no patterns remain in errors. No patterns remain in errors. So residual autocorrelation is checked to ensure no patterns remain in errors. Now, residual noise. Residuals should ideally represent random noise once the model has captured all explainable patterns in the data. It's very, very important. Improving models using residuals. Residual patterns can guide feature engineering, model selection, and hyperparameter tuning. Persistent pattern in residuals indicate areas for improvement. By understanding and analyzing residuals, AI practitioners can build more robust and accurate models. Thank you.